I'm a student here at Roanoke-Chowan, and I'm here to kind of present the Mechatronics program that we have here. Here, let me get one of these. This is about the program and everything. Mechatronics is a type of engineering degree that is really designed for industry. It's designed for automation. It's really a hybrid between electrical, computer, and mechanical engineering. So taking this system, for instance, you have pneumatics here that would be more of a mechanical role. You have solenoids and everything and machined parts that somebody would have to design for a system like this. You have electrical engineering, computer engineering, and the PLCs and controls that you have here. And all of it wraps together to make an autonomous system here that you could, say for instance, for this one, it's more of a parts checker. So you get a part off of an assembly line, say it's one of these. So you're designing some valve system. And you have two inlets here, two through holes, and then one on the side that screws in. So what you do is, say it comes off the assembly line, you put it in a system that was supposed to check it like this. You would start it, goes through automatically. Oh. If it works correctly, it does. Reset that and try doing it manually. Okay. That should work. There we go. All right, so it checked the part right there to make sure that it was in the correct dimensions, correct specs, everything. Now it goes over here. It should. Goodness. Oh, it's always when you go to show it to somebody, it doesn't want to work. At the end here, it's supposed to go on a track and go to the end of your conveyor belt. That means that your part was good, it checked it, it did everything that a person would need to do. This process could require up to 3 people. You know, parts are coming off an assembly line, and just rapid fire. You need to grab them, you need to check them, you need to make sure there's no defects in your parts, there's nothing wrong with an injected molded piece or some part off of another autonomous process. Doing a system like this could save time, it can save money for people, and it requires more jobs for people who understand PLCs and higher level engineering jobs, like mechatronics. Now, you can do multiple things. So say, put one of these in here. It didn't drill a hole, it didn't put any of the necessary parts in it, it just skipped through all those. It needs to come out before it gets shipped off to somebody. So you put one of these in here. Let's see if it works this time. Put it in. It didn't work. So it detected it through the systems here. This one here is a device to detect what type of part it is. You know, is it the correct height? Is it aluminum or is it plastic? This one here detects the clearances on it, so it would send a laser through it. If the laser makes it to the other side, then there's a hole in there. So it knows that the part is good and can continue on. This one over here, which if it made it through, so let's grab one that will make it through. Make sure I put it in the correct orientation. We'll send it through. It'll come over here. This one here will make sure that the part is correctly sitting in the tray. It checked it, it was good. Then it comes here, and that's checking the orientation of your part. So if, say, it came in upside down, that servo over there would flip it. But since it didn't flip it, the part is good, and it didn't need to be, so it's good on its conveyor belt. Now, the good thing about this is that you can send in as many as you want, and you can make the process autonomous. So this can continue for hours. You don't have to employ people to work 24/7, and you can have a system like this run all night. System, say, for like a 3D printer that we have in there that we'll go around and see in a little bit. Those systems, that part that's printing on it right now has been printing for 20 hours currently. I did not check on it. I did not do anything. The part worked fine. It has been printing for 20 hours. Nobody had to go in there and do that. If you were to ask, say, a machinist to make a part like that, and that's not going to be to a machinist, specifications. It's not going to be within 1/1000th of a degree of tolerance for whatever part you need. But if you were, say, prototyping something and you didn't want to pay a machinist to work so many hours just for a part that might not even fit in your application, rapid fire prototyping like that on a printer like that you can just print it all night, come the next morning, my part fits, I'm going to order this from a machinist, I'm going to get him to machine it in degree, check it in my tolerances for whatever I'm doing. You've just saved time there. You don't have to have somebody machine you a wrong sized part, and you can rapid fire prototype that way. Other systems like the circuit boards over here is another part of mechatronics that you deal with. You deal with motors, switches, circuits like this. So here we have switches, we have a set of resistors, diodes, transformers, fan motors, buzzers. We'll actually get to put some of this together, show how push buttons and no push buttons work, how this could be applied, how normal wiring works. And we also have some in the other room that we'll go to, like lathes and machining stuff, and they check tolerances, and they teach the students out here how to properly align stuff into machines. Because a big part of putting stuff together and making sure that it works properly the first time you put it in is making sure that you check your tolerances, you put it in correctly, you don't misalign something. Because in high-speed systems, fast-moving parts, say like in an airplane or in a helicopter, you can't have something out of tolerance. If you're moving it very fast, it will mess up your motor, it will mess up whatever you're using, and it'll mess the whole thing up, ruin your part, ruin your motor, everything. So we'll get to see that in a little bit. But for now, if y'all would like to do a little hands-on with both of these, we can do that. I can show you how the switches will be set up, and we can make a fan and a light turn on. All right. All right, so who would like, we can separate, we can work some on this and on this here. This is more hands-on than that. That's more, putting a part in, seeing if it's right, learning how it would put it through automatically. So if you want to do that, we can.
So this seems very upper level.
Yes.
So your typical student, are they, how old are they?
High school students, 17. The thing is, they don't need to necessarily know how the PLCs work. So that's the logic down here, these lights and wires and everything that goes in here, this here, and all those main boards down there. They don't need to know how that works. Okay. I don't know how that works.
Okay.
All they need to know is what is this system looking for? Okay. What do I need to do to troubleshoot it if something goes wrong? Okay. They don't necessarily need to know how to, write the code for it.
So they can come out of high school and go into this program?
Yes, yes. It's designed for high school students, also continuing ed students, coming back in. But it has been very popular with high school students. Okay. So if anybody wants to, grab a part over here and we can start loading them in, you can get hands-on with it. All right, you put it in that metal tube there. All right. Now, if you press that start button there, everything's on automatic, so you don't have to. Oh, there's one. Was it?
Did you get kicked out?
Oh, so I'm sorry. You put it in up a different way. If it can't clear the other side, it'll automatically shut off like that, which is good. Because you hate for a system like that, you get a jam, or say the part went on like that, and it went forward and it just slid down. When it checks it right here, it won't move forward. It'll stop the program. Usually it'll alert somebody. This isn't really set up for a industry type situation. But it's good that it would stop, because if it kept going, it would either ruin this here, or it would ruin your part, or it would ruin all the housing. So when you put it in, make sure you do it like level like that so it can come out the other side here. And just put it at the bottom there. If you want to press start. Oh, sorry, switch it over to manual to reset it. There we go. Now you can push it back in, and hopefully it works this time.
Third time's the charm.
There we go.
So with these machines, are they programmed to only work with a certain item, or are you all able to reprogram for different things?
For this one, it's only able for a certain like, you know, cube there. Yeah, and it does range just a little bit. Like they have aluminum cubes in here that also work for it. But this is very specialized to this.
It's specialized to that particular item.
Yes, yes.
All right, so now about the printer, the 3D printer. I know it uses plastic stuff, right?
Yes.
Is there any type of equipment that does like metal printing?
They do.
Customized?
They have printers specialized for metal printing. Yep, it's a different caliber of printer due to the high temperatures that you have to run materials through in metal applications.
Okay.
But because, you know, because metals have a lot higher melting point than plastics do. But they do have them. They're much more expensive than, say, a 3D printer like that. Both of those combined, I believe, are like $2,500. A metal one would cost $6,000 just for one printer.
Do y'all practice on those machines here?
Not the metal ones. Those are more industry specialized.
Okay.
You know, rapid prototyping just for metals.
Okay. Are there any industries in this area that do that?
Not many.
The reason I'm asking is when you said something about the printer and you said something about metal, my husband had a kit that I bought him for birthday or something, and somebody took one of the balls off of it, and he can't. The manufacturer doesn't fill the ball. by
Carver
itself.
Machine Works. Something called Carver Machine Works
Where's that?
in Winterville, I think. Might be
Down
in
the street from
Washington,
us. Okay.
but a machinist could recreate.
Could
That's what
recreate
you're
that.
looking for, is
Yeah.
a machinist.
Yeah, because he can't find it
Oh.
anywhere.
These systems,
Oh, it's turned on. So here, let me reset it. And fix
So we
that.
were trying to figure out, could we put more than one in?
You can.
And it works?
And that's another plus side of an autonomous system like this. Say you did have a part of this machining process that required people. You can't run them all night. It's not ethical, and you probably shouldn't do it anyway. But if you do that and say they made a whole stockpile of them, and this machine can only run so fast, you could build a taller system like this and just have whatever stock they have at the end of the day run through the night. At the end of the day, they've all been processed, they've been checked, QC'd, they're done. You can send them off just like that. We can put them in just face down like that. These should work here. Every one of those that are in there should work and go to the end. You can go ahead and let me reset that, put it back on auto. If you want to start doing it again, you can. If anybody else wants to try it, did any of y'all want to try the system? Oh, want to do this? All right, so I'm going to switch over to this and start explaining some of this. All right, so I'm going to try to, just with my little circuit knowledge that I have, one physics course under my belt, I'll try to explain this.
that is one more than I have.
All right, so we have two power supply inputs. So I'm pretty sure we're all familiar with AC, what we have in our walls, and what we have in our phones, which is DC. Reason we use it in our phones is because you can't store AC due to its like bidirectional kind of properties. You know, it goes forward and it goes backwards when it alternates at 60 hertz. DC, however, you can store, which is why we use it in phones. You can use it at lower voltages. There's benefits with transistors. All that. That doesn't really matter. There's two different types of voltages. Not every component is intercompatible with it. Stuff does funky things when you put AC through it. So if I put AC through that fan motor there, what it would do, as long as there's not a diode in there, is would go forward for half the number of cycles and go backwards for the other number of cycles. But if you want it to go in a single direction, you know, blowing air out in a certain way, you would use DC. So what we have here is a 24 volt DC that's hooked up through the AC power source here. It goes into probably a full bridge rectifier to get it to DC. But what we can do is hook up a light. So these lights here, I'm pretty sure they're LEDs, so they have to have a built-in resistor. You can hook them up to a switch, so like these lights here. Now these run off of an inverter. That's why they use so much. That's why they use so much current compared to these. I'll actually show something cool that you can do with this due to how much low current they use. So let's hook this up to a switch. So all a switch is a break in a circuit. So if you imagine it as a wire, if you have a button that presses down that breaks the circuit, you can close a wire by pressing a button. So if we think about that in that way, if you hook up two positive ends to the end of your switch, all you're doing is creating a break that you can control. So if we hook this positive here up to the positive end of your DC voltage, hook it up to the positive end of the LED, that is important that you keep it that way because LEDs are directional systems. These diodes here are what LEDs are. LED stands for light emitting diode. So you can only put current in one direction. If you force current in the other direction, say I hook this negative up here. I should probably turn that off because I shouldn't do that. It would stop the current flow. Now, if I pushed enough voltage, say 24 volts, it would push it in the other direction and burn the LED up. Now, I'm going to hook that back up to the positive, turn the switch back on. Didn't really matter due to the low current draw anyway, but that, you hook that up here, and you hook that one up here, light will turn on. You can flip the switch off, flip it on. Works like a regular light switch.
That's because you have it going 2 ways now?
Yes. So what this is doing is saying, if I connected this lead here to this lead here, that's connected, right? So it's running from the positive source of the battery to the negative in the direction that the diode asked it to be. But what this is just a break in the line that you control. So you can turn that on and off, which is cool. But another thing that you can do is turn the switch off, disconnect it from power, and the light is still on.
Because DC stores power.
Yes, but you have to have a battery in the circuit. Can you tell me why the light stays on and you can actually see it's dimming?
Is it residual in the wire?
Not in the wire, but there is capacitors in there that they use. So the capacitors store current, which is why they tell you it's dangerous to open up electronics. If you open up your microwave capacitors, this is thinking back to like 2000 days when they had tube TVs, but if you had a tube, back in the 2000s. I know I was young, but yeah, I remember tube TVs. You weren't supposed to open them because they had high voltage capacitors.
Where's the capacitor? Is it part of the battery or part of the light?
It's part of the circuit that makes sure it makes sure that the voltage stays steady. So capacitors act more like a reservoir of water, if you could think of it that way. If you were to try to deplete your water supply out of a hose, you would rather have a supply there that you could continue supplying current, which is more related to a voltage scenario and electronic scenario here, to make sure that your voltage doesn't dip. So if you were to supply a load that this could not handle, so say that wall outlet is providing 20 amps to this outlet. And then that goes through a separate system that turns it into DC, but that DC circuit can only handle so much current before you either break the system or the voltage starts to drop. So adding a capacitor in there prevents that current draw from doing that. And you can see the light's turned off because the light does use current. It uses a very little amount due to it being an LED on the degree of 0.01 amps. But let's plug it back in and show some other cool things that we can do with it. So the light turns back on because we provided power, replenished the capacitors, and switched back over to DC. Now, normally in a system like this, due to this one having a built-in resistor, we don't do it. Anytime you deal with LEDs, you're supposed to use a resistor because all they are is it's kind of a gate. It allows things in, but it doesn't let them back through the other way, even though it might try. So with an AC system, that's how they convert over to DC. You can use 4 diodes here to then cut off certain bits of your AC sine wave and turn it into a directional current. Now what we can do instead of turning on a light and make something a little bit more productive with the switch over here, I'm going to turn that off because this is a little bit loud. Make sure I'm running the correct wires. We can set it to a piezo buzzer. It uses the piezoelectric effect. Don't ask me how it works. It's a little bit above my head, but you put a little bit of current in and it buzzes. A good use of a piezo buzzer, especially with a light system here, is you could run this through this light so that every time the light turns on, you hear a buzzer. Now you could hook this up to, say, an alarm system. Let me make sure I wire this correctly before I burn something up. That should, that didn't work. What do you think about this? Positive end there needs to go. I want to say what I can do is hook it up this way. That way we get both. There we go. So every time the light turns on, the buzzer turns on. You can hook this up to a system like an alarm. So if, say, you had a sensor on the door, and every time the door was opened, a light would turn on and then a buzzer would turn on. you could be then alerted if somebody opened your door.
Okay, I can alarm science. So, let's say we had someone who was deaf, right? That could be used the same way, like if somebody pressed the doorbell,
Yep.
a light would come on?
A light would come on. Yep, you could do something like that.
Exact opposite.
Yep,
Okay, cool.
same thing.
Like with Alzheimer's patients, whenever they leave their seat, wheelchair, make a noise.
You could do that, yeah.
If they try to sneak out of the house.
Now, I wouldn't use a buzzer that big. That might scare them, but
Oh, I was saying to let the other people in the house know. So.
that's fair. But yeah, that's something that you can do with that. Let's see, what else? Oh, we can hook it up to a separate type of switch called a single pole double throw. So let me pull all these off here. What? Single pole double throw, which means, so if you look at the diagram here, there's 2 outputs and 1 input. So it's a break in a line that connects 2 separate wires. So in one position, it will turn on one system, and the other system, it will turn on the second system. So if you connect these wires the same way that we did the other ones, 2 outputs to our 2 outputted lights, so let's say the yellow one, and let's say this one here. And if I connect this one here, that one there, this one here, that one here, this one.
Now, what year student is you?
Me? I'm a, I want to say I'm a junior. It's weird because, you know, when you take community college classes, a lot of those classifications really go out the window. It's more, do what?
You're very,
All right.
very knowledgeable. Yeah, I guess that's it. How far along?
Do
in the
what?
program?
What drove you to the field?
I got really into electrical because of my dad. He's the person that's actually head of this program. He is a licensed electrician. He did industrial. I think they didn't, because mechatronics is a very new degree. Like, companies don't really hire people who are mechatronics because they don't know about it. It's not that they're not qualified, and as soon as a company sees that they're qualified with a mechatronics engineering degree, they hire them.
Okay.
It's more that people are getting accustomed to this new term, more of a hybrid between engineering degrees than a separate engineering degree. They don't specialize in mechanical engineering. They don't specialize in electrical engineering. They're not going to be the ones that do the theory on how that LED works. How are they going to design an LED like that?
It's more of an applied.
It's more of an applied science, yes. More of a jack of all trades of engineering. So when companies realize that's what the type of person that you have on your hands when you come out of a degree like this, it will immediately hire somebody like that.
Because that means you can do a little bit of everything.
A little bit of everything, and especially in a community college like this, you get experience. You have shops like that where you're working with it. Like you're not sitting down and going, this is my calculations for my motor. My motor drop's going to be 90% assumed efficiency. Assuming all that, you actually apply it. So when they go in there, they don't immediately fall apart once the theory breaks down when you're applying actual applications, like with resistors. So you could design a resistor circuit, right? So we're limiting the amount of current that goes to these LEDs. That's what a resistor does. It resists the flow of current. You could do that, and all those numbers will work out, but if you don't realize that they're going to create heat, and they can only dissipate a certain amount of heat, as I was trying to do over there with a separate circuit system, I burned up 3 resistors because it could not handle the current. If somebody did not have that application and did not use it, they would not know that that's what would happen. They wouldn't need to do power dissipation calculations. They just wouldn't realize that. They wouldn't realize that they can only put a certain amount of current through it. That's something you really only get when you start applying it, when stuff starts breaking down.
Yeah, so you guys would be good with troubleshooting.
Yeah,
Like,
and that's what
they're
companies want.
specialized engineers, but you troubleshoot.
Yeah.
When things go wrong.
So this is, we've now been to 4 community colleges, and this is the first one that we've heard that term,
What?
Mechatronics.
Mechatronics.
So,
Yeah.
do you know, do the other community colleges have it? We just haven't heard about it yet, or do you know that?
I don't believe.
It's like y'all's thing.
It's one of our things. Like it's a good bit of this building specifically about what they do. But mechatronics doesn't get classified always as mechatronics.
Okay.
Sometimes they
Could be
do
called
it.
something else at a different school.
It could be like an industrial degree, but when you have something like mechatronics where they put in that degree more an expectation that you don't have to learn what every other engineer learns. You know, doing charge calculations on infinitesimal disks of charge to determine voltages. That's something an electrical engineer might have to do. But
I mean, they don't have to.
yeah, well, they would never use it in something like this. When you have the expectation that all they need to know is how to apply it and how to apply it in a way that the company can benefit,
Right.
you really have a good applicant. And you don't have to worry about someone that's not going to come in there knowledgeable or come in there and not know what they're doing and need that training experience that takes time away from being a productive company. You already have that as a student coming out of a program like this.
How many students do y'all have?
I think the current number is in the tens. I think 10s and 12s in certain classes. Now, a PLC class might not have 10 people. It might have 3 or 4. But that's a more advanced kind of coding level, in like electrical engineering class. These you expect like around 12 people. But
And how long is the program? Like, is it just, I mean,
I
maybe just
believe
one semester.
I believe it's 2. I want to say not 2. I'm sorry, 2 years. I believe it's a 2-year degree, 4 semesters, and I don't know if there is a summer associated with that. I don't have the course up with me. I believe it's a 2-year though.
And where have your students gone off and gotten jobs? Do you know? Is there a list for that?
Oh yes, there is a list in here. I think in Viva Berry Plastics. I think Nucor has Nucor Steel and Roanoke Electric.
Okay.
So a lot of those local companies. I mean, Berry Plastics is in Ahoskie, not too far away from here, probably about 5-10 minutes away. Other companies around here are very close. I mean, I'm sure Warehouse would hire a student out of here.
Is there a list of like how much your kids are, how much money they're making after they finish this program?
Yes, it is.
I just need to read through it.
Yes. I thought it was written down here. I believe, I want to say it's $28 an hour coming out of the program.
Okay. Yes.
Yeah. Yeah. And I mean, as you get more experience, this is an engineering. It's not a 4-year engineering degree, but it is a 2-year advanced manufacturing degree.
Awesome.
But I mean, that's not bad. And as you get more experience, you still have the knowledge that someone in mechatronics would need to advance further and get higher amounts of salary. Did y'all want to work on this system any or touch it? I mean, you can make a fan go. You can do whatever circuit that you'd like to.
Yeah, you can make a thing.
All right. So I got it hooked up to a single pole double throw right now, so you can make a light turn on with it, or you can make one of these. You can make the yellow light turn on with the fan. You can make the red light turn on with the fan. You can take it completely apart, make that fan turn on with a push button, a non-contact push button.
Let's take it all apart.
All right. Let me turn it off because it.
I would have just taken this.
All right. So let's see.
Let's turn the light on first.
All right. So let's start here at the power supply. So you need to bring one off the positive, which usually the positive is positive 24 volts, and usually the negative is 0 volts, which means ground. So if you actually tied that to a ground pin, then you could connect everything to a ground, meaning like a piece of metal on that. It makes some wiring diagrams easier to draw them that way.
Okay.
So would you like to hook it up to a push button? So this one breaks the circuit. This one connects the circuit when you push it.
See a push button.
Okay, so a push button, so we put it in the positive. You can run this one to the other leg of the positive of any of the lights or the fan if you'd like to.
Okay, so I'm going to do the brake light.
All right. So the
And
brown
this
is
is
positive. Yep.
Okay. And I connect this.
Back to the original, back to the positive, because it's more of a break in your line.
Okay, so this is positive. All right, and is this positive?
Yes.
Okay, so it goes
Yep.
positive.
Because you're really just trying to lead it from the positive leg all the way up here and then right back
Okay,
to the
so
negative.
connecting From here to here, just using 2 different
Yep.
wires. All right.
And then you can connect the negative up there if you'd like to, back to the negative of your power supply.
Okay. And then this negative goes here.
Yep. Oh, sorry. All right, now let me make sure the switch is on. You can press that push button, it should turn it on.
Hey, my brake lights work.
Yep. That actually would be how a brake light worked. You press it in, you can actually hear it sometimes, the actuating switch go in. Now you could do a non-contact push button. I'm sorry, I think that stands for something else. I'm used to, that's what it stands for in like an IC, which is an integrated circuit. So you can actually build systems like this onto smaller systems and use them for generalized applications. So say you needed 2 diodes hooked up with 2 sets of resistors, and that's a really general application for something. And then you just vary a couple other things on the outside of the circuit. You could put all that together into something called an IC, or the integrated circuit like I was talking about, and you could do a lot of applications with it. You can do, so if going back to that single pole double throw, if you wanted a system that blinks, so say a caution light, you could have something that has a timer circuit in it that then alternates between those 2 circuits.
Okay.
Now, a cheap and dirty way to do it is to hook it up to AC and have it go back and forth, because it's a diode at a block current.
Okay.
But if you wanted to hook it up to that, this one here, which is turns on, but when you press it, turns off, so it breaks the circuit when you press it.
Okay.
That could be used in an alarm system. Again, if you wanted to do it that way, you could have the door press on the button so that it's closed, so that no light or no alarm is sounding. And when you press or move the door, when you let go of the switch, light turns on, alarm goes off. That way, you know, it could be as simple as a button, or it could be as complex as a laser system that you put in there to detect if the door opens.
So like, okay, in a washing machine, for example, you raise the lid, the cycle is on, and it stops. Is it similar with this?
It would be similar, yes. That one might be more mechanical with the lid. It could have something to do with the hinges pressing something when it opens. I mean, if you mess around with it enough, you could probably figure it out. You know, if you open it a certain amount of way, does it turn off? Is it the lip that connects and locks the door down? Is that what it does? You could do that if you lifted it past the locking point and check it that way. That's on an actuating switch at the top of it. Yep, you can actually see it on some of them, and if you actually hold it down, you can turn off the lights while it's in it.
So it's not like this where you push the button, it's totally different. It's more mechanical.
Actually, it is exactly this. It's just a switch, but it's in a different kind of arrangement. It's more, it looks more like a light switch here, but as the door closes on it, it pushes it down and then turns it off. So it's similar to that. But yeah. Oh, yeah. Anybody else want to do a circuit? We haven't hooked the fan up yet. Anybody want to volunteer to do that? All right. Now, the thing about fans, this one's hooked up to a DC motor, so I'm sure you're familiar with wiring stuff.
A little bit.
So do you want to hook it up to a switch? You know, you can hook up to a single pole, single throw, since this is a single system. We can hook it up here first, if you want to take the lead.
Sure.
All right.
We were over there working on that, so I'm going straight towards your fan.
All right. So you can hook it into the
Big,
positive.
where we at?
We're on
positive
positive.
here. All right. I'm too old to see positive and negative. There we go. All right.
All right. If you want to lead it back to the power supply.
It should go on and stay on because I didn't put it on a switch, right?
Yes, sir. All right.
All right, so now we want to move it to a switch, right? Is that what we
Yep.
wanted to do?
Now take the positive leads here. You can still keep it hooked up to the power supply. And you can hook up the negative too. That's just fine. You'll need another one at some point. Single pole, single throw, which means only one input and one output. If you did single pole double throw, that's one input, 2 outputs. Now, dual pole dual throw, too many duals, goes dual input and there's 4 outputs because each single pole double throw, which is connected to another single pole double throw, has a second 2 sets of outputs. But we can just hook it up to this one. So run it from.
So basically what you're saying is if we want this switch to operate 2 things like the buzzer and the fan, we would go in here, then we would go from here to one to the
Yep,
other. Got it.
exactly.
Which one you want me to do? This one?
Either one. Yep, that's a single pole.
Positive going to be left?
Yep, this all runs from the positive. It's more of a controlled disconnect of your positive wire, if you can think of it that way. Honestly, you could probably hook it up to the negative if you really wanted to. Yep. Now, the thing about DC motors, the way that you reverse them is reversing the polarity. Now, I don't want to do that because there might be a diode in there, and this is 24 volts DC, so I don't really want to put 24 volts on the other side of a diode. Probably will break through it. But that's actually how you reverse them. So if you have, say, a trolling motor on your boat, what it would do is reverse the polarity of your battery and send it to the motor, and it would reverse the direction in which it moves. Now, AC doesn't work that way. I'm not as familiar with AC as I am with DC. But, yeah. Now we got the fan hooked up.
What is an example of a dual output for a fan?
That would just be any device. So more, so say for this single pole dual throw that we have here, if you wanted to hook up two outputs to your single input being your battery, and you wanted to control two things. So with one throw up, I want this light to turn on. With a throw down, I want a buzzer to turn on. Or I want a fan to turn on, and then I want a buzzer to turn on. That's how you would hook up this one. Now, if you did one of these, you'd have two sets of inputs, which I assume you could just tie to the other leg of your battery.
But you could put brakes off of one and not the other, correct?
Do what?
When you're going out from that, you could put brakes, other switches, and
Yes,
lights
you could.
off of one and just straight to the fan with the other.
You could, yes.
Okay.
Yep. You could hook it up this way. I hope this works. Haven't tried the dual pole dual throw. Let's run this back. Yeah, I hope it doesn't. It's an expensive board. It's not as cheap as breadboard, so. All right, let's hope I do this right.
Should we all put our glasses on?
As long it's more, you don't want to see magic smoke coming out, which is where it, white smoke comes out of the machine. It's bad. Only had that happen a couple of times. Only a couple. All right, let's see if I should probably turn that off. Okay, let's run it back here.
And to think that you can have all that in your car, so that, like the very
Yeah.
simple pressing a brake battery.
I mean, you could fit all of these components down. I mean, maybe not a transformer. That's actually what, if you could, I don't know if they have one out there. On the lines there, those cylindrical devices, those are transformers. They transform down what the power line sends out, which is, I believe, 10,800 volts, three-phase AC. They take one leg off of it, single phase. They transform it down to 240, which is what, actually everything runs on 240. It's just split phase 120 power. But that's what one of these transformers does. So you can have different windings, and the different windings result in different voltages. It's actually a pretty simple calculation for it. But that's AC. All we're worried about today is DC. So let's see if this works. Okay. Perfect. And the fan's on. So the fan turns on when the yellow light turns on, and when you flip it the other way, those two lights turn on, the fan turns off, and the yellow light turns off. Oh.
So guys in car clubs, they do like really cool stuff with their cars and all that stuff. So you'd be the person that could hook them up if they wanted to do some special stuff.
I'd hope I could hook something up like that. I hadn't tried the double throw, but I'm glad that worked.
Write that down to you.
Yeah. Oh. Any other questions?
Well, that just showed, okay, you tried it for the first time, right?
Mm-hmm.
But because you know the general concept behind it, you applied it in a totally different way than you had before.
Yes.
Which is an excellent example of what you're learning in this program.
Yes,
So
yes,
that's
ma'am.
Yeah.
And I mean, that goes off.
Very
Yep.
simple.
Something very simple goes into something a little bit more difficult.
Yeah.
Now, another thing about this double pole one here is, since there's two inputs, it doesn't have to come from this battery. I could hook it up to 24 volts AC, and on that line of my circuit, it'll get AC current. Or I could hook it up to a 9 volt, a 5 volt battery, a 3 volt battery. I could hook up to a 100 volt battery. I might jump across some of these due to the high voltage, but you know, I could hook up whatever I wanted to the two inputs. I just ran a jumper between the two, but that's another. It's the versatility of some of this simplistic electronics. You could use resistors to regulate a voltage to run a whole camper off of a battery. You could go from 14.8 volts to 12 volts and run your whole system just off a couple of ICs, some resistors, and diodes. You know.
So if we have a student, what type of student, high school student, do you think would be more interested in this? Somebody that's more mathy or more figure it out kind of kid? Or?
I think a person who more a figure it out kind of kid, but also someone that's not scared of math. Because like I said, resistors need power dissipation calculations. You need, I believe it's, I want to say the square root of your current over your resistance is your resistor calculation for heat dissipation. These, I don't know what the wattage is, which is why I didn't run anything through the resistors. I didn't want to burn them up. I'd have to replace them. But the ones that I was using on that other circuit that I tried to make before everybody got here that didn't end up working out, it was 1/8 of a watt. So those students who used it and tried to figure it out, they would have to be very careful about how they run those resistors. If they run too much current through them, it'll burn them up, it'll break your circuit. It's really just memorizing a couple formulas and keeping a couple things in mind for, you know, math. It's more of a figure it out kind of kid.
Are they having to take required math courses as part of the program?
I believe the only math course that they require is just remedial math. You know, just a standard across the board. If your English class requires it, this class will require it. I don't believe they require calculus for this. Don't quote me on that. I would look at the program. I think I do have a couple of program sheets around here. I think they might be over here.
And would it be possible for a high school student to take a class like this? Do you have a summer type program?
I believe there are some.
To be graduates.
It's open to high school students, so anyone, I believe the CCP students, which is Career and College Promise, I believe they can do it. I think this is, yep, this is the whole program here. I can hand this out to y'all. I don't know how many copies I have. But.
I was going to kind of look at
Oh,
it and hand it.
yes, yep. Okay, gotcha. Here, I'll pass out a couple copies. This is the whole program, you know, what GPA you need. Gotcha. Let me pass it. Pass a couple to y'all. Oh, you good? Welcome. Yes, sir. I'm going to leave any extras here that anybody needs or wants.
Thank you for doing such a good job at explaining it.
Yes, ma'am. Glad to be able to show you all this, and hopefully it gets everybody interested in the program. Y'all have any questions on the what would it be? I guess an outline of the course.
Are we gonna see what's been printed?
Yeah, what's been printed?
Yes, we can. Got an interesting one for y'all. It uses supports, pretty complex structures. You know, it's nothing too difficult, but you know, it's something fun and interesting.
How far along are you in this program? Have you finished?
I'm not in the program. I'm just you know, the instructor is my dad, so I'm just helping him out, and you know.
Okay.
Yes, ma'am.
Just playing around.
Yes, ma'am. Well, I am familiar with his curriculum, but I am an aspiring electrical engineer, so I know a little bit about that, given that mechatronics touches electrical engineering. Yeah.
I know what you're doing.
But if everybody wants to head on to, let me check the time. I want to make sure I'm not running over on, you know. Okay. About About 5 minutes? Okay, that gives us enough time to check on this, and we can circle around, look at the shop in here. I don't want to, I don't know if they want to, we can go through this door here. All right. I know it's a little bit messy in here. It's just one of the downsides of, printing and, all right, well, I guess y'all understand then. Y'all might have to get a little bit closer to it. The way the printer works is it puts the bed all the way up and prints downwards. I can turn a light on. So you can actually lift this up and see what it's printing if everybody wants to come over. So these things on the side here are supports for it. Any structure that has an overhang needs a support. An overhang is a 45-degree kind of, anything that goes over that really does need a support. Now what this is a model of one of these printer extruders. So I think I actually have one. Here we go. Now this doesn't have the head on it like those three are printing there, but this is a 3D printer extruder. So you got a fan that cools off the heating nozzle, and you have the actual heating element in here. What it does is on the side here, you have a roll of plastic. Actually, let's see if I have one out. Here you go. If y'all want to look at that, you can pass it around if you'd like to. That's what actually makes these things. So it's, I believe it's 1.75 millimeters in diameter. Is extruded through the head. It goes to a different size. I believe it's I want to say 0.5 millimeters. Then extruded, and then it just makes repetitive layers of whatever 3D model that you create. Now this is good for rapid prototyping. It's not as good for multiples of a single prototype, but it's good at a very, not machine tolerance, but not carving it out of wood. It gets you a reasonable level of tolerance to check whatever part you design. Now these specifically are not as much parts for an engineering type of application, but more of a fun design that you can create with it. I mainly made this one to show how the printer can handle overhangs, complex models, rounded shapes, and just be able to do it without stringing between it and messing your parts up. Yeah, do y'all have any questions about 3D printing? Do it.
What is printing? Where is that?
Right in here. Yep, it's still making it. Yep, you can look and take a closer look if anybody else wants to come in and look at it. But, yep, we have two of them. This one over here, I've been troubleshooting just a little bit of issues with bed leveling, but it works on the same principle, But having multiple printers like this, or sets of smaller ones that you can do faster prototyping on, you could have one running over here, and then if you make a design alteration, put it on one of these. This one finishes, you check whatever you need to, then you fix whatever was wrong with the previous one, and then you continue like that. It's much faster paced prototyping. You don't have to send it off to a manufacturer to get samples, say overseas, or maybe even at a company here that takes time to make whatever product you've designed. You can make it here in your office, in your job, and not have to outsource that and wait weeks to make sure that your parts and tolerance are correct. And that, you can see how this uses all the ideals of mechatronics, automation, using just electronics to work for you and not for you to work for those electronics. Any questions? Want to close that back up for anything gets in there? Yes. Yes. Did y'all want to look at the shop they have here for a little bit of the machining and stuff that they have, and kind of?
How much longer is that going to be cooking?
What? Another 4 or 5 hours.
4 or 5 hours?
Yes, ma'am. It's been going for 22 hours already. The more complex the model, the longer it takes, so that it makes your part correctly. But if y'all want to go down this way, and we can take a look at the shop real quick before y'all have to go. I hope this door is unlocked. and it is not.
Have the credit card?
I will have to credit card it. It's mainly because the lock was put on backwards, so it's flipped around the incorrect way. There we go. Wouldn't keep the camera on for that one. But this is the shop that we have here. We have the material. That's more for they're trying to get that up and running for trying to show them more industry type manufacturing. This checks the tolerance of motors, showing them how to properly put something on there. Making sure that your bearings are correct, that your wheelie's within tolerance, so that it doesn't vibrate the motor and cause the shaft to mess up the actual motor there. They actually learn how to wire up these motors. 3-phase AC, single-phase AC, DC. Over here, this is kind of showing them residential wiring. You got your panel over here. Really hope this isn't live. You got your panel here, breakers in here. You can run it to an outlet. They show you how to do home runs to panels, jumping off of a receptacle, running over to light switches. Not going to put my hand in there. Running them up to lights, everything like that. Over here is more solar panels. Controls on that. They design systems, handle influxes of current. Solar panels only generate electricity during the day, so you have to have systems that can handle that and then know when to not pull power from them and just turn off at night. I don't believe this one moves. There are separate electronics and stuff for ones that do move to best optimize capturing sunlight. You could use linear algebra to make sure that your vectors are orthogonal to each other, perpendicular. But this is more trying to show them inverting the power, because solar panels create DC energy, and we use AC as in our power grids and everywhere else, outlets, all that. And it's used to actually, I believe, power this motor here, and they're trying to work to see if they can get this one fixed. It's really just been a learning process for these students to try to get this up and running and really teach them. And we have a couple of lathe machines over here. This one here